Hello ACOM. We are here to complete your design task of evaluating our vehicle infrastructure for the future. Design concept of a careless future. The idea of a careless future came about due to the incredible amount of greenhouse gases automobiles produce every year. Carbon emissions from cars are a predominant source of the world's total greenhouse gases, and therefore needs to be limited or potentially liquidated in order for the environment to be saved. The four concepts are self-driving bikes, maglev trains, self-driving trucks, and increased tram networks. So, this presentation will be evaluating each of these concepts and will be using the criteria to find out what concept is the best at what task. Cost is very important for any design as that it is increasingly important drivers for clients expecting maximum return on good design. Innovativeness is important as we are talking about the future and it needs to be assessed how new the concept will be as this will draw more attention to it and hype around a product can create a large income. Safety is arguably the most important criteria as it can cause harm to the user then that can have huge legal implications and cost the company lots of money. As this project is for how we must environmentally sustainable in the future, it is important to analyze how sustainable each of the concepts are. Therefore, we have incorporated it as one of the criteria we are judging these concepts on. Lastly, efficiency. This essentially means how many people can use the means of transportations at one time.
Our intent is to make cities inclusive, safe, resilient, and sustainable, which would be targeting the UN Sustainability Goal 11 of sustainable cities and communities. The concept of a self-driving bike aligns with multiple goals from this part of the UN sustainability goals, such as safe, affordable, accessible, and sustainable transport systems. With the bikes being electric, they won't release harmful gases into the atmosphere. They would run off the same system that most Queensland uses with the go-cards, so the trips will be affordable, accessible, and also, their manufacturing process is cheaper than most other types of transport. After deciding on a concept of self-driving bikes, material choices had to be made in order to design a proper concept. 4130 steel alloys were decided to be the best material for the bicycle frame. This is due to its high elastic modulus of 190 to 210 GPa. This therefore means that it has a higher stiffness as well as a high fatigue failure. This makes the material good under tensile forces. To find the approximate cost of the concept, we will look at the average weight of steel-framed bikes and the price of 4130 steel alloy. Steel-framed bikes weigh in at approximately 12.133596 kilograms. This is without tyres, seat, and gear system. The price of 4130 steel alloy is $15.89 per 1.211092 kilograms. Therefore, it costs on average $149.20 per bicycle frame. And with this average pair of wheels costing about $100 for high-quality steel compound wheel set, this costs about $260 per bicycle. And with the technology not being available yet, we cannot calculate the cost of that, but it is assumed that it will be relatively expensive, with Tesla prices already far more expensive than most other automobiles due to the self-driving technology and long-lasting electric battery life. So we can safely assume it will cost upwards of $300 per bicycle, and plus the cost of the construction of the charging bays, the overall cost will be quite expensive after the initial cost of constructing everything. The system should sustain itself with the go-kart-like idea where people will pay to use the mode of transport and will in hand fund power consumption, wages and repairs for the self-driving bikes, therefore giving this a 2 in cost. The self-driving bikes would fall under a variation creative concept, giving it a 2 in the innovative criteria. With the pre-existing technology in Tesla's self-driving cars and Honda's self-balancing motorbikes, this makes for a concept that is already in production, although there is not much development directly linked to the self-balancing bikes and driving bicycles. Therefore, it is only a variation concept. The variation concept takes one pre-existing idea, product, or concept and adds a new innovative feature to the product. In hand with this product, it takes the idea of electric bikes to the pre-existing technology of self-driving and self-balancing. This product doesn't feature much safety at all. The self-driving bikes work very similarly to regular bikes, and the only form of protection would be helmets and or knee or elbow pads. Although the bike's self-balancing technology would prevent anyone from falling off it, is a rare case that someone does fall off, there isn't much protection at all bearing anything that the user is wearing. This gives it a 1 in the safety reason due to its lack of protection. Environmental sustainability was one of the main reasons for the liquidation of the private car ownership and therefore must be used as a criterion for these concepts. Overall, the self-driving bikes are very environmentally friendly as they produce little to no carbon emissions because they are electric. In the future, battery life and charging power will be greatly increased, so the bikes will still be able to run for a long time and will be charged very quickly. This gives self-driving bikes a 3 in environmental sustainability. Efficiency, meaning how many people it can hold, is a criterion we chose because it was important to try each of the public transport fit as many people as possible. Unfortunately, bikes can only fit one person per bike, therefore making it very inefficient and only giving it a score of 1 for efficiency. Overall, the self-driving bike got a 9 out of 15, which makes it pretty average. Although it does make for good short-distance travel from major destinations such as train and tram stops to home, it is great for environmental sustainability, which is arguably the most important criterion.
One of our solutions to our careless future plan for the Gold Coast is the maglev train. To effectively evaluate the maglev train, we're using the same criteria used for the other solutions. This criteria is formed from cost, innovativeness, safety, environmental sustainability, and efficiency. From this criteria, we can evaluate the effectiveness of the solution and determine which is the best solution. Each will be marked out of 3, and the highest total score will be the best solution. Maglev train technology currently is too expensive to practically be used with current technology, which is its major drawback. However, with technology advancing by 2050, we believe a new form of ceramic or new method of cooling could be applied, drastically decreasing costs. The maglev train is a very quiet form of transportation compared to other forms of trains. Its current design makes it appear as aesthetic as possible whilst limiting noise pollution, including combating sonic booms through tunnels, making a good option for transport through populated areas. It does, however, require its own rails, which must be specifically crafted to support magnetic levitation of the train. The maglev train is a very safe form of transport as a result of its design and safety measures. However, there have been fatal crashes involving the maglev train in the last 10 years, so there is still further to go to make the train safer for the public. The maglev train helps support UN Sustainability Goal 11, which refers to sustainable cities and communities. It does this by providing efficient, safe, and potentially affordable transport for communities. Renewable energy is able to be used to cool the superconductors once it's efficient, creating a sustainable method of transportation. This provides the everyday person with sustainable transport, which is part of Goal 11, which is our main reason for selecting the maglev train as one of our solutions. Efficiency is a big positive for the maglev train. It is able to carry large amounts of people over long distances at very high speeds, making it a very practical form of long-distance transport. Overall, the maglev train is a very efficient and safe method of long-distance transportation, which is already being tested within cities around the world. For cost, it scores a 1 out of 3, innovativeness 2 out of 3, safety 3 out of 3, environmental sustainability 2 out of 3, and for efficiency 3 out of 3, with a total score of 11 out of 15.
The three-wheeled bike was designed to meet the requirements of many users and attract a wider variety of customers such as elderly people, intoxicated people, families with children, provide a safe method of transportation, and align with the UN Sustainable Development Goal 11, by making the bike affordable, accessible, safe, and environmentally friendly. All of this was achieved by using common materials and technology which does not require a highly trained person to assemble, significantly reducing the production cost. Accessible as the bike can be easily accessed through an app which will send a message to the bike making it come to you autonomously. The bike is also safe since it's fitted with self-driving technology, meaning it is able to predict accidents before they happen and avoid them. And finally, environmentally friendly since the bike is powered by an electric engine which can be easily recharged back at the station without resulting in the release of any toxic gases. The bike is not tied to one specific target market. Instead, it includes a wider range of demographics and ages, thanks to its ease of use. That allows disabled people, intoxicated people to use it, as well as the multiple seats in the back with lots of space being optimal for families with children, and people wanting to travel in groups. Cost-wise, the bike has a large frame made of aluminium and an engine to power the bike in case the user is not able to pedal, and self-driving technology, coming to the conclusion that the estimated total cost for the bike is $500 to $700 per bike. The design concept has a sleek design which is both aerodynamic and also very aesthetically pleasing, increasing the possibility of it becoming a tourist attraction in the future, further expanding its target market. As mentioned before, the bike is fitted with self-driving technology, meaning it can predict an accident before it happens and avoid it, making it very safe for anyone to use. Finally, in terms of the design concept feasibility, self-driving and safety technology in the bike already exists in most modern cars nowadays, and developing the frame of the bike will be the same as developing the frame of any current vehicle, as aluminium is one of the easiest materials to work with next to steel. In conclusion, if we were to give each aspect a score from 1 to 3, with 1 being very bad, 2 being average, and 3 for very good, cost would get a score of 2 for costing more than other concept to produce, innovativeness gets a score of 2 for technology present in the bike, safety gets a score of 3 for having autonomous driving and ability to avoid crashes, environmental sustainability gets a score of 3 for having an electric engine which does not release any harmful gases as well as operate on renewable energy. And finally, efficiency gets a score of 3 for having enough seats to fit 4 people at once, almost as good as cars, giving a total score of 13 out of 15 points.
As previously stated, our concept is focused on targeting the US Sustainable Goal 11, which includes developing cities that are inclusive, safe, resilient, and sustainable. To meet this goal, we had to create links between urban and rural areas. To do this, we have decided to combine our self-driving bikes with a self-driving delivery truck system. The first section in the evaluation criteria is cost. To get an idea of the cost, we would need to evaluate the price of materials used in regular trucks that are used today in comparison to the chosen material for our concept, carbon fibre. The most used material when manufacturing a truck is usually steel or a steel alloy. These usually range between $1 to $10 per kilogram, compared to carbon fibre, which can be anywhere upwards of $100 per kilogram. However, by 2050, manufacturing processes and new technologies will most likely decrease the cost of carbon fibre immensely. Nonetheless, it is still far more expensive than the materials we use in present society. In addition, as the technology is not readily available yet, we cannot accurately calculate how expensive the self-driving technology is. Although Tesla, a company that manufactures self-driving cars, sell their cars much more expensive than regular cars, and therefore it can be assumed that the technology needed for the trucks will also be extremely expensive. Finally, the construction of charging points will also be an additional cost for this concept. By evaluating the cost of steel compared to carbon fibre, combined with the cost of self-driving technologies and the construction of charging points, it can be concluded that the self-driving delivery trucks would be very costly and therefore are given a 1 for the cost criteria. The self-driving trucks would fall under the combination section in the taxonomy of creative design, which would indicate that it is a 2 in this criteria. This means it must use 2 or more pre-existing technologies to create a new one. In this instance, we have used the technology of self-driving car combined with that of a truck. Safety is a major feature with the self-driving truck system. As there are absolutely no passengers in the truck or on the road, if a crash did occur, there is a very minimal chance that anybody would get injured. In addition, crashes will occur much less, as by 2050 the self-driving technology will be extremely reliable and most likely only affected by other factors such as natural disasters. The truck would immensely decrease the number of injuries and deaths on the road and therefore is given a 3 for safety. Environmental sustainability was the main reason for creating a carless city. Due to the fact that all cars will be taken off the road, the gas emissions will dramatically decrease. Furthermore, the self-driving trucks run completely off solar energy and therefore will be completely sustainable as solar energy is an infinite resource. Due to all this, the self-driving truck system is also given a 3 for environmental sustainability. The final criteria we have decided to evaluate is efficiency. This includes things such as how much the product can hold and how quickly it can get a job done. Although the trucks will be reasonably big, there will still obviously be some limitations. Nonetheless, with no cars on the road and using the self-driving technology, the delivery time will be extremely quick. Taking this all into consideration, the truck system is given a 2 for efficiency. Overall, the self-driving truck system received a total of 11 out of 15 for our criteria, which is a great result. To improve on the concept, a cheaper production for carbon fibre will need to be created. Nonetheless, the self-driving truck will be a great system to incorporate with our self-driving bikes to create a carless future. To conclude, we have been given the goal of creating a carless city by 2050. Our proposed concept is the use of self-driving bikes combined with existing services such as trams and trains and also a new self-driving delivery truck system. To analyse each of our aspects, we used a criteria system which included cost, innovativeness, safety, environmental sustainability, and efficiency. For each section, the concepts were ranked 1 to 3, 3 being the best and 1 being the worst, then were given a total score out of 15. With total scores of 9 out of 15 for self-driving bikes, 13 out of 15 for three-wheeled bikes, 11 out of 15 for the maglev train, and 11 out of 15 for the self-driving truck system, our entire concept received a total score of 44 out of 60. With a score of almost 75%, it can be concluded that the proposed idea would be a great solution for a carless future in 2050.